As you can see here, there is a labeled diagram of a subduction zone. And what a subduction zone is when two tectonic plates come together and one goes under the other. So if you look back at our satellite image of what is Central America, okay, you can see right here this ocean trench that is actually a subduction zone, okay, where you have two different tectonic plates and one is going under the other. The reason it goes under the other is due to the density of the plates. Okay. Oceanic crust is denser, and the reason it is denser than continental crust is because there is a presence of water within the crust, which weighs it down. Okay. So what happens is deep within the core of the planet, okay, there is massive amount of heat and energy that is produced. That heat and energy that is produced within the core heats the mantle, okay, which is the second layer of the Earth. As that is heated, it heats and rises, okay, in what we call convection currents. It works very, very similar to how ovens work. As the heat rises, okay, it moves towards the top, and as it cools, it goes down towards the core of the planet, okay. So this massive convection current actually drives tectonic plates and actually moves them. On average, they move about 3 inches per year, and they are moved by these convection currents, which are created from heat within the planet itself. Since oceanic crust is more dense, okay, as it hits this continental plate, okay, it is going to subduct. That's why it's called a subduction zone. Remember, sub means under, so it's going to go under. Okay. As it goes under, okay, it's going to create an ocean trench. It's going to continue down into the heat of the core and the mantle. And as it does that, what is actually going to happen is the water that is trapped within the oceanic crust will start to escape. As that oceanic crust escapes, or water escapes from the oceanic crust, the crust will actually start to melt at times. Okay? As the oceanic crust melts and the water escapes, it actually melts parts of the continental crust. That's what you can see here. Magma with H2O, which is water, will escape, okay, and start to flow higher within the crust, and it will actually form inland volcanoes, as you can see here. Okay. This magma, because we call it magma when it's below the Earth's surface, it's lava as it escapes to the Earth's surface. This magma is rich in silica, so it has a high silica content. And what that does is it makes this magma very, very blocky, okay, and very chunky. The problem with that is it is the opposite of the low silica content of Hawaiian volcanoes, which flows, in a sense, like water. This blocky, silica-rich magma creates very, very dense rock. Rock that does not allow carbon dioxide and other gases to escape. So as these volcanoes are built up, gas gets trapped. As that gas is trapped, eventually what will happen is heat and pressure will cause the volcano to collapse, creating a caldera, which multiple pockets of steam and gas, heat and energy will escape, often in a violent eruption. Okay. Furthermore, as these two plates collide into each other and the oceanic crust subducts, you're going to get more than likely a coastal mountain range. This coastal mountain range is due to the impact of two tectonic plates colliding. And the process that creates, okay, this oceanic crust to subduct all starts at the mid-ocean ridge. There's actually a mountain range within each ocean. Okay, there's small cavities within oceanic crust. Hot magma comes up, causing sea floor spreading. This spreading of the sea floor causes new oceanic crust to be created, okay, which causes it to spread and eventually subduct in a subduction zone. The reason why this is important when we're talking about the Olmec civilization is because if we look at a map of Central America, and this is more of Central America, Panama, Nicaragua, Honduras, and Guatemala, you can see here of the major volcanoes of the region. Okay, those volcanoes actually extend up into southern Mexico from our other map. We know that those volcanoes are created by subduction zone of oceanic crust subducting beneath continental crust, creating inland volcanoes. We can look back at our satellite image and verify this. We can see right here, there is the ocean trench. So we know that there is oceanic crust going beneath continental crust. We can see the raised terrain, which is indicative of mountain ranges, okay, created by volcanic activity, okay, and extends up north. And we can also verify that on our map of major volcanoes.